cannot get back into the school anymore, at least not easily. So my smart board is out of commission. We're going to try something new today. This will be what we used to do on a smart board. Give it as on the board in the book notes, if you will. Let's take a look at what we learned from section 2 of chapter 9. We are talking about cell division. And we know that in cell division, mitotic division, a cell has a life cycle. That life cycle will result in two genetically identical cells to what you started with. Let's undo that one if we can. Froze up. There we go. Undid a little too much. Now we got lost. Cell cycle. And that cell cycle is divided into three major parts. Interphase, this out of the way. Mitosis, and over here, I always spell that wrong. Cytokinesis. So we've got interphase, mitosis, and cytokinesis for a typical cell cycle for a cell that is going to make two identical copies of itself. Interphase, we also know, was divided into parts. The first part we talked about is G1. In G1, we have normal growth, that cell is doing what it does. Does its job. And for some reason, in this case, that cell decides to divide. If it decides to divide, it will go from G1 into S. And the unique thing about S, the synthesis part of the cell cycle, is you get a DNA copy of all the DNA. And that's really the only time in the life of a cell that you will get an entirely new set of DNA. So we've got two sets of DNA, two sets of instructions to build a cell after S is done. Before we go to mitosis, there is also G2, which we said was last minute growth. From G2 to mitosis, we go to prophase, metaphase, anaphase, and telophase. Pro, meta, ana, tele. And mitosis was division or separation of the nucleus. Cytokinesis didn't have individual parts, it's just the separation of the other things, the cytoplasm, the two membranes, are membranes into two cells. So, during this process, we also talked about the DNA. And let's see, I need to introduce some new colors here. So we'll go with red for first kind of DNA. That first DNA, which we had during interphase, and we will have it during cytokinesis, is chromatin. Chromatin was the opened up form of DNA capable of being read, usable, very good for what the cell needs to be alive, but not so good for moving it around between the two new cells. So let's change it to a blue and talk about the DNA that we have during mitosis. During mitosis, it is called chromosomes. Not quite that simple though, because the definition of a chromosome is going to change between a chromosome in prophase and metaphase and what a chromosome is made up of in anaphase and telophase. In prophase and metaphase, a chromosome is two sister chromatids joined by centromeres. Now we know that at the end of metaphase, the beginning of anaphase, that centromere splits. So that means our chromosome in anaphase and telophase is one sister chromatid. Okay, I'm going to change the page here and talk a little more about chromosomes and what happens in prophase and metaphase. Let's see if I can do that. Today probably can't. Oh, I'll save this. So we'll call this, oh, that's good, image 001. And start with a fresh slate. So, stages of mitosis. The first stage we said was prophase. And I told you to remember prophase as preparation. Preparation for division. The nuclear membrane disappears, the chromosomes go, the DNA goes from chromatin to chromosomes. The centrioles migrate to opposite sides of the cell. And from prophase, we go to metaphase. And in metaphase, those chromosomes line up in the middle. Here, again, a chromosome is two sister chromatids joined by a centromere. When that centromere splits, we start anaphase and chromosomes move away from each other. And till we get to, telophase, in which we get two nuclei forming. Those two nuclei form after the two chromosomes separate to opposite sides of the cell. And over here, when we say chromosome, we mean one sister chromatid. All right, so let's take a little bit closer look at that. And that telophase will be followed by cytokinesis. New save. Let's hope this comes up. Oh, it does. O2. So, let's start with a cell and interphase. Cell and interphase is going to have one copy of each of its chromosomes. One copy of each chromosome. So let's take an imaginary cell and say it has one chromosome. So in a cell and interphase in the nucleus, there's one chromosome. We can't see it because it's in the form of chromatin. But let's just pretend it stays in the form of a chromosome as we're going through this. So in the nucleus of this cell, we have one chromosome. We're going to decide, this cell decides it needs to divide, so it goes through S. And when it goes through S, we now have two copies of that chromosome. So this cell is still an interphase, but now it's gone through G2, and we are going to come out of G2 and go into prophase. These two copies are going to join each other with a centromere in the form of a chromosome. So now we have visible chromosomes. They will stay that way till we go to anaphase, when the centromere splits at the end of metaphase. And now we have still two copies, but they are not joined together. Each one of those is now called two chromosomes, but those chromosomes are identical to each other. Those chromosomes will go back once we finish telophase. Whoops, I should write it over here. Telophase. If I can erase that. Getting there. So telophase. And now, as we go back into interphase, we are right back here, which is why we say we have two genetically identical cells. All right, hope that clears up some of the stuff about mitosis. Please check with me, email me, message me, however you can. And if this doesn't make sense, and even if it does make sense, let me know you guys are still out there.